The law of conservation of mass. This was a review learning target from last semester, but it's super imperative that we master this learning target for this unit as well. It's one of the underlying fundamental concepts for chemistry. So the first thing about the law of conservation of mass, and you should be jotting this down underneath your lodge, is that the mass of your reactants, which are your substances on the left side of your chemical equation, should always equal to the mass of your products, the substances on the right-hand side of your chemical equation. Another way to think about the law of conservation of mass is that matter can never be created or destroyed. It is what it is. The matter can never be created or destroyed. An example of a scenario in which we have the law of conservation of mass in effect is if you start off with 100 grams of reactants at the beginning of the chemical reaction, you should also end up with 100 grams of products. You may have different products, but you should have the same mass, 100 grams. See, Leo finished with his key points. He's waiting patiently. Nadia, April. At the very bottom of your first page, you should have your key term for a balanced equation. Today we're going to be practicing how to determine whether an equation is balanced or not. And when we have a balanced equation, that means we have the same number of atoms for each type of element on both sides of the equation. When you are ready, go ahead and flip to the second page of your handout and indicate that you're ready to move forward. So before we go over an example, which I will guide you guys through, we're going to write down the 3 steps that you need to know and follow in order to determine whether an equation is balanced or not. The first lesson from this unit, we learned how to calculate the number of atoms for each type of element given a chemical formula. Now we're going to use that knowledge to make sure a chemical equation is balanced. So the first thing is, again, we're going to count all of the atoms on each side, the left side and the right side, or reactants and products. The second thing is that the number of each atom type, or type of element, needs to be the same on both sides, the reactant side and the product side. last step is that if you notice that there is a type of atom that does not have the same number on both sides, that means the chemical equation is not balanced. I will walk you guys through this for the first example. COD's finished, Minecraft, Viviana, Dahlia, Maria, Brent. About another 15 seconds and then we'll move on to the example problem. 5. Alright. So for determining balanced equations, remove that. You'll be given a chemical equation, just any random chemical equation, and it is your responsibility to determine whether the equation is balanced or not. And so you have to compare the number of certain types of atoms on the reactant side and the product side and make sure that they're equal numbers. And so the first thing that you should be able to do is determine which side is the reactant side and which side is the product side. So if we look at this chemical equation, we'll know which one is the reactant side and which one is the product side. Right. So I made it a little bit easy for you guys. I already labeled the chemical formula as reactants versus products. The second thing that we're going to do is similar to what we were doing last week. We're going to make sure we count the total number of atoms for each type of element. So let's go ahead and do that. You guys have a minute and a half, and then I'll call on certain students to fill out the numbers for each type of element. See Julio calculating the numbers for each type of atom. Elizabeth is already finished. Wilbur. The rest is on the product side. JC is moving on to the product side. Luis is finished. Katie is moving on to the product side. Most of you guys are finished. I'm going to call out student volunteers so Martha can give you guys a participation point. On the reactant side only, the number of atoms, just list them down. Let's hear from Maria. 2, 3. how did Ellie get 3 atoms instead of 2? Over? Right, so Wilbur said there's 2 here, there's also 1 oxygen here. We can add them together to get 3. So it should be 3 oxygen, not 2. Make sure you have that on your notes if you don't. And now, if we were to determine an equation if it's balanced or not, we need to make sure that both numbers on both sides are equal to each other. And if we look down here, for every element we have the same number of atoms. This means that the equation is balanced. So you would circle Y for yes. Go ahead and complete the check for understanding at the very bottom of your notes. And then we'll again go over the answers. Diego has an excellent question. What if the total number was equal to each other, but the number of atoms were different? It would not be a balanced equation. Everything has to be equal to each other. If you can list out the number of atoms per reactants only. Yeah, I'll put that for now. But let's make sure that this is correct. Claudia, do you see something that might be a different number on the reactor side? So let's make sure. For hydrogen, we do have 4, right? We have 2 times 2, which is 4. This is correct. For oxygen, how many atoms should we have? It's not 4, Morgan. Why is it 2 and not 4? Right, so oxygen has a subscript of 2, but it does not have a coefficient. So we don't multiply it by anything. It should be not 4, what should it be, Cesar? 2. Which means our total number is what, over? 6. And then for the product side, Alexis, if you can list out the numbers just going down starting from hydrogen. So is this a balanced equation, Julio?
Yeah.
Yes, it is. Everything matches up, line for line, 4, 4, 2, 2, 6, 6. So this is a balanced chemical equation. I'm going to pass out the classwork, and then you're going to do the first 3 problems on your own with your group, and then we'll go over 1 additional problem. Spy talk, that means it does not have to be silent. We'll be whispering to people at your group, only the people at your group. Morgan, hold on 1 second.